welcome to this lesson video, part 2 for writing the equation from a graph. The previous video I ran out of time to finish up our notes. So, let's just remember standard form versus vertex form. That's kind of what we're talking about. Standard form, ax squared plus bx plus c. Obviously, we have no parentheses. Vertex form, we do. And I am able to derive the vertex straight from the equation. Remember, we do the opposite of what we see. So instead of a negative h, the opposite would be positive h. Remember the little trick I tell you, x lies, but y tells the truth. So the y value would be whatever k, what number represents k. Okay? So that's just a quick recap. Here, we've got to write an equation of a graph in standard form that has the given vertex and passes through some point. So since I have the vertex, I'm going to start by putting it in vertex form, as much as I can anyway. So I don't know a, so I'm going to have y equals a. However, if my vertex is negative 1, 3, what would the group had to have been, x what, for me to have taken out a negative 1? Remember, since x lies, it must have been a plus 1. And then what number would have been out here that would have made me put a 3 as my y value? Well, it would have been plus 3 because y tells the truth and we keep it as it is. Now, there's a problem with this though. This a value, I need to know what a is. So for my second step, that's what I need to do, find a. Okay, and how am I going to do that? I'm going to do that by using this extra point that they gave us for its x and y values. Because when you have an ordered pair, do you agree it gives you an x number and a y number? So I'm going to plug these numbers in. So in place of y, I'm going to put a 1. I still don't know a, but in place of x, I'm going to put negative 2, and I'm going to keep everything else. Okay. So I think I'm going to work inside of here first. What is negative 2 plus a 1? Well, that's negative 1, and we're going to square that. And then what's negative 1 squared? Well, that's just a positive 1. So I really have 1 equals 1a plus 3, because negative 1 squared is 1. Okay. So now I need to subtract 3, because I want to get a by itself, because you know that's what I'm trying to find to begin with, right? So I'd have negative 2 equals 1a. So either you divide or you know that 1a is the same as just a. So we know that a is negative 2. Okay, so, but where do I go from here? Well, step 3 is to plug a back into the very beginning. So go back to step 1 and replace your a with the negative 2. Notice how I kept x and y in here because we're writing equations. So I should still see x and y in my final answer. So the last step, the directions say standard form, and this is vertex form. So I've got to convert to standard form. Now, if you have our previous video, that was example 1, convert to standard form. So if you refer to your notes or the video, this is going back to example 1 to show you how to convert. So what we do is we FOIL these guys. So off to the side, you know, to square something, it means to take that x plus 1 times itself. So if I FOIL that, oops, there's a 1 there. To FOIL that, we would do our firsts. X times x is x squared. Our outers, x times 1 is 1x. Our inners, 1 times x is 1x. And then our lasts, 1 times 1 is a 1. So I have like terms here that I can add together. And when I add them, I end up with x squared plus 2x plus 1. Now, going back to where we started here in step 3, I was supposed to FOIL this guy. Once I FOIL him, I ixnay the group and replace it with what I got from FOILing. So the -2 is there, but in the parentheses I now have x squared plus 2x plus 1. My square is gone, because that's why I FOILed. I took it times itself, so it's just this guy, and then that loner 3 at the end, he's still there. So my next set of directions is to distribute that -2. And so I would end up with y equals -2x squared minus 4x minus 2 plus a 3. Last thing is, hey, you've got some like terms here at the end, bro. So add them, clean this guy up. So as a final answer, it would be negative, I'm not sure just what happened. There you go. Sorry about that. That was weird. Negative 2x squared minus 4x, and then plus a 1 at the end. So there would be my equation in standard form that goes through the vertex -1, 3, and the point -2, 1. All right, so what do we have next? Oh, now I give you a picture. And the directions say write the graph in vertex form. Okay, so let's see, what do I know from this picture? Well, this is my vertex, and I know that that point is 2, 3. And I'm thinking about the one we just did, how they gave me some random point. So like, there's a point on my graph, 0, 5. Maybe I need that. Well, since I know the vertex, why don't I do like what I did on the last one, where I plug in as much as I can. So what would have been in this group for me to have taken 2 as my x for my vertex? It would have been a -2, because I would have had to do the opposite. And what would have been on the outside for me to take a 3? It would have been a +3. Okay, well, yeah, this is just like the one we just did. If I use this extra point, I can plug in for my x and my y. So y would be 5, because, you know, I don't know a. That's a problem, so I can plug in 0 and 5 as a slick trick to find a. So 5 equals a times 0 minus 2, -2 squared plus 3. And then if I square -2, that's a 4. So I really have 4a plus 3. So then I want to subtract my 3 here. So I have 2 equals 4a. And then if I divide by 4, 2/4, that reduces to a half. So take this and put it back into the beginning up here. 1/2 x minus 2 squared plus 3. But now let's go back to the directions. Remember it asked for vertex form, and well, hey, that's vertex form, so I can stop. Cha-ching! I don't have to do that extra work like the last one. Cool beans. All right, we've got one more graph, so we might as well look at it. Okay, so, that's my vertex. Now notice I'm counting by 2's. So the vertex is actually -1, 9. And I think I'm going to use this as my extra point. Make sure you write it correctly. It's 2, 0, not 0, 2. Okay, so if that's my vertex, that means the group must have been x plus 1 squared with a +9 at the end. And these are my extra values, my extra points that I can plug in for x and y to know what a equals. So let's see. So that way you can say, you can see where the x and y went, now that I'm color coding them for you. Okay, so there's the y, there's the x. So what do I want to do here? Well, 2 plus 1 is 3, so I'm really looking at 3 squared. And 3 squared is 9, so I really have 9 times a plus 9. So then I could subtract this 9. So negative 9 equals 9a. So if I divide, I'll get a by itself, and a will equal negative 1. So go back all the way to the beginning and plug that in for a. And yeah, vertex form again is what the directions say. So bada boom, bada bing, I'm done. All right, so that finishes up our examples for writing the equation of a graph. Oh, excuse me, writing the equation from a graph. So make sure you have your note sheet completed. Keep learning, guys. I will see you next time.